next we have about 10 minutes before we go to the next session, and we have one item remaining, so that is the named entity recognition. So that's something that we are releasing today. We have been working over it with a couple of students and with Dr. Rudra Murthy at IBM Research India. So Rudra is here with us, and he'll briefly walk us through what the Indic NER system is, and maybe a little demo of that. Maybe run the inference, and again, notebooks are available, so you can always try all this offline. Yeah, over to you, Rudra.
Hi, everyone. So today I'll be giving a brief summary of our work where we have been creating named entity recognition data sets for around 11 Indian languages, and also the models with the multilingual NER model, which we have trained here. To summarize, so we have created a large-scale NER data set. We are calling it as Namapadam data set. It's for around 11 Indic languages. The Indian languages are Assamese, Bengali, Gujarati, Hindi, Kannada, Malayalam, Marathi, Odia, Punjabi, Tamil, and Telugu. And this dataset is created in an automated fashion via entity projection. I'll be talking about the algorithm in detail. We have also released a small annotated test set for around 8 Indic languages. For 5 Indic languages, namely Bengali, Hindi, Kannada, Malayalam, and Marathi. The test set comprises of more than 500 sentences, which amounts to roughly 10,000 tokens. We also have Tamil, Telugu, and Gujarati, comprising of around 50 sentences. Both these data sets are manually annotated. The small data set is annotated by one human annotator, whereas the large test set is annotated by 2 annotators. So we also released this multilingual Indic NER model, where we fine-tune a MBERT model on these 11 Indic languages. And the model, it has a compact size of around 159 million parameters. So all the models and code are made publicly available in this particular link. So what is named entity recognition? So it's a task of identifying or extracting named entities in a given piece of text. So for example, in this sentence, right? We want to say that Asin Ilkini Center is name of location, AI for Bharat is an organization. 28 July could be a date entity. IT Madras is an organization. So what are some of the key challenges in Indic languages? The major challenge is lack of capitalization feature. So unlike English, where all the proper nouns, the first letter of all the proper nouns are in uppercase, that's not the case with Indic languages. And also ambiguity between proper nouns and common nouns. So for example, when someone says Santosh, do they refer to happiness or name of a person? Such ambiguity is pretty high when it comes to Indian languages. Morphological variation. So for morphologically rich languages, say the same word can take multiple inflections depending on what's the plurality, what's the case of the word, and so on. Say this creates data sparsity and results in low performance for the task of entity recognition. And also a key challenge is small label data. So if you look at the data set which is available for Indic languages, we hardly have, say, more than 10K sentences per language. So that's also the key challenge. Going to the technique of how we created this Namapadam data set. So what we did was we took the Samanantar parallel corpus. So Samanantar parallel corpus contains English to Indian language translations available. Then what we do is we take the English portion of the parallel corpus. We take existing fine-tuned English NER model, infer the entity labels. For example, in this case, India is the largest country in South Asia. So when we pass through this English NER model, we might get, say, India is the name of its a location entity. South Asia is a location entity. We also have the corresponding translation in the Indian language. What we do is we use word level alignments. So these word level alignments can be obtained from off-the-shelf aligners like Giza++, Fast Align, Awesome Line, and so on. Now, once we have the word alignments, what we do is we look at the corresponding entity in the English and see what words it's aligned to the what words it is aligned in the Indian language and project the labels. So the location entity gets projected from India to Bharat. South Asia, again, the location entity gets projected to Dakshina Asia. So once we have project these entities, we have created this Namapadam dataset. And then what we do is we fine-tune MBERT model to get Indic NER model. So this model is trained on the data of around 11 languages. So this was with respect to the dataset creation. Now let's look at some of the dataset statistics. So here you can see that if you look at this table, right? 9 out of 11 languages, they have more than 400K sentences, and it has more than 100K named entities, combined person, location, organization. And a bit of, one question arises is how good the data is. So for this, what we did was we did an evaluation on the small test set comprising of 50 sentences. There, those 50 sentences were manually annotated. And when we compared the gold label and the label obtained from the projection method, we observed that the F-score was greater than 70 for many languages. So another set of experiments in order to ensure that the quality of the data is good, what we did was we fine-tuned MBERT model on different data sets and evaluated it on the in-house test data which we have created. So this is the graph which shows the diagram. So the blue bar represents the MBERT model fine-tuned on Namapadam dataset and tested on our Namapadam test portion. Similarly, models trained on FIRE dataset and tested on the test set is indicated by the red bars. The same goes for orange bar for WikiANN, and the green bar is for multi-core NER dataset. It's a SEMEVAL 2021 dataset for Bengali and Hindi. And lastly, Seafield Lab recently released a very large data set for Hindi comprising of around 1 lakh sentences manually annotated by a single annotator. So we took the trained portion of the data set, fine-tuned the model, and tested on our in-house test data. And here we can clearly observe the performance gains. So the models trained using our synthetically created data set outperforms existing models trained on existing data sets by a huge margin. And also we report, say, individual language wise F scores on the test set. As you can see, for many languages, we achieve F score greater than 80 using our Namapadam trained data set. So we have released a data set comprising of around 11 languages. As part of future work, what we wanted to do is we want to cover all the 22 languages which is listed in the Indian Constitution. Thanks, everyone.